All right, so in this video, we want to solve this quadratic polynomial inequality over here, and it's a double inequality. So when we have a quadratic equation in the middle and we have a double inequality, we actually have to split this up into two different equations. So the first one will just be that left side over there, or two different inequalities, I should say. And the other one will be the right side, which will be over here, x minus 4 times x plus 2 divided by x minus 2 square has to be less than 1. So the goal of this question is to solve both of these two inequalities separately and then combine the final solutions by overlapping whatever intervals we get as the solution. So let's start by solving this one here. I'm going to move the minus 2 to this side and make it a plus 2 because we want to start by having one side equal to 0. Then I want to make a common denominator. So I'm going to multiply x minus 2 squared on the top and bottom over here. And now I have a common denominator of x minus 2 squared. Then I want to expand out these two brackets by FOIL. So I'll do this a bit quick. That's going to be x squared plus 2x minus 4x is minus 2x minus 8. So I combine like terms in the same step. And over here, it will be x squared minus 4x plus 4. Denominator just stays the same. And then I'm going to distribute this 2 into the bracket. And finally, I'm going to combine like terms in the top. Negative 8, positive 8 just cancel out, so there's no constant left. So now I'm left with solving this inequality over here. So before I solve this one, I'll just factor the top. Oops, just x. Common factor over there. And before I solve this on a number line, I'll do the same thing for this one. And then I'll go on to my, sorry, not number line, I'll do sign charts for this video, but you could also do it on a number line. So I'm going to subtract the 1 on this side, make it less than 0. I'm going to make a common denominator, so I'm going to multiply x minus 2 squared on the top and bottom here. Oops, this is a minus 4, not a plus 4. Then I'll expand my two brackets out by FOIL. And now I will distribute this negative into the bracket. I'll combine like terms in the top here. So x squared, negative x squared cancel. I'm left with 2x minus 12. X minus 2 squared is less than 0. Then I can factor this as well. So 2x minus 6 over x minus 2 squared less than 0. Okay, now that I got my two inequalities fully factored, I just have to solve each of these. You can either use a number line or a sign chart. I'm going to do a sign chart for this one just to explain sign charts. So I'm going to start with my columns over here. Just going to put all my factors over here. Again, there's multiple ways you can do this, but this is the way that I'm going to show it with the factors over here and then the intervals over here. So for the intervals, we need the solutions to these equations. So if I look at this equation here, I know that my vertical asymptote is just a solution to the denominator, is x equals 2, and my zeros are x-intercepts, the solutions to the top, which are 0 and positive 10 over 3. So I'm going to use these numbers over here for my intervals. Your interval will always start with a round bracket and negative infinity, and then you will go to the smallest of these three numbers. The smallest of these three numbers is 0. So from negative infinity till 0. Now we have a less than equal sign here, which means you need to use square brackets for the numbers that include for the zeros. This is a square bracket here, meaning it's all inclusive. Next, I'll go from this number 0 till my next smallest number here, which is 2. Now, 2 is a vertical asymptote. Vertical asymptotes always have round brackets because they're non-inclusive. Next, I'm going to go from 2 till my next number, which is 10 over 3. 10 over 3 is a 0, and it's inclusive in this table. And the last range I'm going to have is from 10 over 3 to infinity. So now I want to do my sign chart for this. I'm going to start by picking numbers between each interval and solving in these formulas. So I'll pick -1 between these two. This is just negative because x is just -1. 3 times -1 is -3 minus 10 is -13. That's negative. Anything whole squared is always positive. I can actually just fill these four as positives because it's whole squared. So two negatives and a positive, if you multiply them, just make a positive. So this interval over here is positive. Let's pick a number between these two. I'll pick +1. +1 is just positive. 3 times 1 minus 10 is -7, so this is negative. Positive, negative, and a positive make a negative. Between these two, I will pick 3. So 3 is just positive. 3 times 3 is 9. 9 minus 10 is negative. So this over here is just going to be negative again. Then over here, I'll pick 5. So 5 is positive. 3 times 5 minus 10 is positive 5. Oops, that's a positive. So these are all positive, which makes this positive. Now this inequality is asking me where this is less than or equal to 0. So I'm going to write my answer on a different page because I need a bit more space. Where is this equation greater than or equal to 0 in the positive intervals is our solution for this one. So the first one is from negative infinity till 0. And then the second one is from 10 over 3 till infinity. I'll keep that on the side for a second. And let's do the sign chart for this one over here. So my vertical asymptotes, solutions to the denominator again is 2. My zeros, solutions to the numerator, there's only 1, which is positive, 6. I'm going to put these on my sign chart for this over here. Multiple different ways this can be done again, but I'm just going to do it in this way because I find it the simplest. So I'm going to start always at negative infinity. This sign is non-inclusive, so all my brackets are going to be round. Doesn't matter because there's no equal sign over here. So my lowest of these two is to 2. And then I'm going to go from 2 till 6. And then I'm going to go from 6 till infinity. If I pick 0 over here, 0 minus 6 is -6, -12. So this is negative. This is whole squared. So these are all positive. Over here, I'll pick 3. 3 minus 6 is negative. So this is also negative. Or if I were to do the final signs here, which are negative, negative. And then if I pick 7, 7 minus 6 is 1 times 2 is 2. So this is positive, positive, positive. So I want to know where this equation is less than 0. This equation is less than 0 in my -2 intervals over here, which are these two. I'm going to copy this on to my other page here, which is -infinity to 2 and 2 comma 6. So now in order to find the final part of my answer, basically to prove this inequality in the question, I need to find where these two intervals overlap. So I'm going to explain it in a longer way, but you can do this quicker. I'm just going to show it to you on a number line, but I suggest doing this without a number line. I would normally not draw a number line for this. I'm just doing it for explanation purposes. So on this number line, I have -infinity at this end and +infinity at this end. I have a value of 0 here. So -infinity to 0 is being covered. -infinity, empty circle. 0 is basically going to be a filled circle because it's inclusive. And then I have from 10 over 3 to positive infinity. You can always put an arrow there for infinity, which people do as well. That's perfectly fine. 10 over 3 is again inclusive, so fill dot. And then if you don't want to put an empty circle, you can just put arrows at the end. That's pretty much the same thing, signifying it's going to infinity and negative infinity. So that's the first thing there. Now I'm going to draw this one over here, which is from -infinity till +2. So -infinity is here, +2 is here, it's non-inclusive. So this one is like this. And then I have from +2 to +6. So +2 is over here. Again, it's going to be an empty circle and it's going to go till +6, which is 10 over 3 is 3.33. So +6 is somewhere over here. That's going, well, I can actually draw it on top of it like this. And then like this. So this is the bottom line is my first interval. The top line is my second interval. Where are these overlapping? That's basically going to be your final solution. So if you look, these two are overlapping from -infinity till 0, and 0 is inclusive because these two lines overlap. And then after that, this is not there in the bottom. And then these two lines overlap from this point till this point here. It doesn't go all the way till infinity. So union and my second range starts at 10 over 3. It's inclusive again over here because the dot is filled. This is just a filled line. And then this point is non-inclusive, which is 6. And this is my final solution to that original inequality.